Hi everybody, my name is Joey and I'm located here in Southern California. I'm known as the Perfect Score Tutor because I've gotten a perfect score on the ACT and SAT multiple times, and I've coached multiple students to do the same on their exams. We're not doing SAT or ACT today, but I thought I'd try my hand at Physics C Mechanics. This is the free response question from Set 1 in 2021, and I just want to see how well I can do here. So I'm going to go through this question and then kind of give you my guess as to how they'll do the scoring distribution. We'll see if I'm right or not when the scoring guidelines come out in a couple weeks or months or however long. So we have this lovely fan cart system. What do we know here? We know that it's 0.5 kilogram, so we know its mass. It's placed on a level horizontal track of negligible friction, as it usually is. So no work done on the system. Fan is turned on and moves to the right, so this is moving to the right. And then the cart travels along the horizontal track and then down an incline. So it's probably going to speed up down here as it goes down. And then motion 1 measures the acceleration from 0 to 3. At T3, the cart makes a smooth transition to the incline. And then motion detector measures the acceleration after 3. The fan exerts the same magnitude of force during the entire motion, and the graphs show the function. For each motion, the positive direction is away from the detector. Okay, so then that makes sense here, right? It's positive because it's moving away from detector 1. So let's figure out, there are 5 blocks here, so 2 divided by 5 is 0.4. So this is going to be 0.8. And then this is going to be negative because it's moving towards the second motion detector, so that'll be 2.4. All right, on the dots below represent the cart. Draw and label forces that act on each cart at each location. Each force must be represented by a distinct arrow on, pointing away from the dot. Okay, so let's see. We have this cart on a horizontal track, so there's no friction. So then what are we going to do? We're going to have FG pointing down, and so you can call it FG or a big G or MG. However you want to label it, as long as it's clearly gravity. Same with this normal force. You want to try to make sure that your arrows are in equal size. Otherwise, the cart would be like floating off the track or something like that. And then we have the force of the fan pushing the cart forward. Same thing over here. Now that it's going down the ramp, we want to have the fan pushing forward. It's going to be the same force. Fan. So let's try to keep our arrows the same here. Same gravitational force as well, pointing straight down. So try to keep that arrow the same size. Here, since the normal force has to be perpendicular to the surface, this normal force is actually going to be smaller because it's going to equal the cosine component of this weight force. And maybe show you that later. But here, I think there's only 3 arrows in each direction because there's no friction acting on the system. Please remember it says don't do components, so you do not want to split up this FG force, even though you will need to do it eventually for part of this problem. Part B says calculate the magnitude of the net force exerted on the fan cart when it's on the horizontal track. So that's pretty easy. We can sum up the forces in the y direction. I don't think we need to, but I'll do it anyways. And like I said, since the cart isn't lifting or like falling into the track, it's going to equal MA, but that MA is going to equal 0. So then at that point, we know that the normal force is just equal to mass times gravity. Okay, that's the FG over there. If we do the sum in the x direction, well, we only have the one force. The force of the fan is going to equal the mass of the fan times the acceleration of the fan, and this is going to be a 1 because it's on the horizontal track. And then if we want to calculate the net force, then we just plug in our numbers. Earlier it said the mass was 0.5 kilogram, and we got the acceleration was 0.8 meters per second squared. So if we multiply those two together, we get the fan is 0.4. Units are newtons, do not forget your newtons. And it says the magnitude, so we don't need the direction at all. So that'll be our answer for part B. Part C asks us to calculate the angle of the incline. So now we're going to sum up the forces Going down the ramp. So I'll just do F and then maybe ramp here. So here's where you want to split up your G vector into its components. So you don't want to do it on this picture on the real test, but I'll just do it here because I already have these arrows drawn. Right, so we have this component perpendicular to the ramp, and we have the component parallel to the ramp. So from geometry, the angle of elevation of the ramp is also going to equal this angle up here. So then since this parallel vector is opposite that angle, this will be mg sine theta. And since this one is adjacent to the angle, this would be mg cosine theta. And so this is something that you should be comfortable with if you're taking AP Physics. So let's add up all the components that are parallel to the ramp. So we have the force of the fan. I'm going to leave that as positive because it's going to be the same direction as the acceleration that's accelerating down the ramp. Then I'm also going to add this mg sine theta force. That's also going down the ramp. And in this case, this is going to equal the mass of the system times A2. Right, we're going to get the A2 from the motion detector here. We want to calculate the angle, so we want to solve for theta here. So before we plug in numbers, let's always make the habit of just isolating the variable without the numbers. So what do we do first? We do mg sine theta is equal to ma2 minus the force of the fan. We divide both sides by mg. So sine theta is equal to ma2 minus the force of the fan divided by mg. And then finally, if we want to solve, we can go like this, and sine inverse ma2 minus force of fan mg. Cool. And now let's plug in the numbers. So I'm a little bit out of space, but we'll try to make do anyways. So 0.5. The acceleration is 2.5. I'm going to treat this positive. I think it's 2.4. Let me double check. 2.4, yeah. Let's keep it positive because I picked the acceleration to be positive going down the ramp. Minus the force of the fan, so that's 0.4. If you got the wrong answer in the first step, you should still be okay plugging in that wrong answer here. And then m times g, so the mass of the fan. And then I'm just going to use 10 for gravity. Sine inverse. You can use 9.8 as well, doesn't matter. So then if you solve this all out, I think this is 0.16. I hope you can see that. It's right on the edge. And then this is the exact answer. If you want to plug this into your calculator too, you can plug that into your calculator. I just don't have my calculator with me. Part D, suppose careful measurement determines the angle of incline to be 3 degrees larger than as calculated in Part C. Consider the following explanation. The scale used to measure the mass of the fan cart was not calibrated properly before the measurement, and this could account for the observed difference in angle. Does the explanation sufficiently account for the observed discrepancy? So basically this question is saying, does mass matter here? So in solving for the angle, it's important that we left it that way. So before plugging numbers, so we could kind of see the relationship. And remember from part A, or this is part B actually, it said the force of the fan is equal to ma1. So if we wanted to rewrite the equation, we could have said sine of theta is equal to ma2. And instead of force of the fan, we say ma1 over mg. And notice how every term has that mass in it, so we can factor out that mass. So what does the angle determine? The angle is dependent on the accelerations and the gravity. So then how would you justify your answer? I wrote something like this. So it's no. According to our calculations, the angle theta is dependent of the mass, independent of the mass, right? That's what happens when you cancel something out, so you can use this phrase independent. Therefore, even though the scale was not calibrated properly, it should not have a significant impact on our calculations. And notice how the question is not asking you for what might have affected it, so you didn't need to go that way. So be careful and make sure you answer the question. So now they did this thing, and they said they repeated this for several trials, and then they gave you different angles of the incline. So what's happening here? As our angle gets bigger, or the sine of our angle gets bigger, the acceleration gets bigger. And that should make sense, right? If the sine of the angle is getting bigger, that means the ramp is getting steeper and steeper and steeper and steeper. So draw a best fit line for the data. So I'm lucky here in that I have a straight line tool. But as long as you draw a line that somewhat goes through the center of the middle of the dots, you should be okay, right? Half of them, approximately half of them should be above, half of them should be below. So what is this? Maybe here? Okay. Make sure it goes halfway through, right? If it's all the way above or all the way below, it wouldn't count. And then using the straight line, calculate the experimental value for gravity, acceleration due to gravity, g. Okay. So usually when they linearize something like this, we want to calculate the slope. So let's find 2 points that my line went through. So here's a corner that it went through. So that one's a corner. And then let's see if there's another good corner. I'll treat this as a corner. Remember that there's room for error here because, you know, it's hard without a ruler here. So let's see, my 1 point is 0.1, comma, these are 0.2s again. So that's going to be 1.8. And this point up here is going to be equivalent to 0.5, comma, 5.6. Okay, and let's see what that slope is. So I'm just going to do it up here. y2 minus y1 over x2 minus x1. 5.6 minus 1 is 4.6. 4.6 minus 0.8 is 3.8 divided by 0.3. Oof. I think that's way off, isn't it? Did I do this right? 5.6, 0.5. Ah, that's why. I made a simple calculation error. It's 0.5 right there. Okay. That's better. Okay, so then this is 0.4. So we can move the decimal over 1, so 38 over 4. And so what is that? 4 goes into 39.5. Okay, so I'm guessing that's going to be my gravity, but I need an equation for this. And thankfully, I think we have an equation from before. And this is down the ramp. Okay, so this is going to be my A2. So what was the equation we had from before? Aha, we're going to take this then. And I can copy paste this. Okay, so I'm going to paste this here. And let's see how we can kind of make this appropriate for y-intercept form. So y-intercept form is, this is going to be y equals mx plus b, right? So if we have y is equal to mx plus b, this is my y, so A2 is going to be my y-axis. My m is going to be my slope, and then the x is going to be whatever this x variable here. So something times sine theta plus something. Right, so something times sine theta plus something. So basically, I'm going to need to rearrange this equation to look like that equation. So now it's telling me to isolate A2. So let's see. If we isolate A2, what do we get? I guess we can still cancel out the m's here, right? So cancel, cancel, cancel. So then what do we get? We get g sine theta is equal to A2 minus A1. Aha! And then g sine theta plus A1 is equal to A2. So this is the slope-intercept form equation of this line. So it just so happens that the slope I just calculated should be equivalent to g. So then I would say g is approximately 9.5. And then always remember your units, meters per second squared. And then part F. Part F says, if the cart were replaced with a second cart of mass 1 kilogram that has a fan that exerts the same magnitude of force as the original fan, explain how the graph given in part E would change. So I'm going to take this thing again. Okay, so that's my equation. So let's see what's going on here. G is the slope. So as long as we're measuring everything correctly, the slope shouldn't change, right? Because G does not depend on mass. G is always going to be 9.8. And so sine of theta is not going to change because we purposely chose different angles. So that's our independent variable. So we got to see if this A1 is going to change. And from earlier, what did we get for A1? We got this equation. We got that the force of the fan was equal to the mass of the fan times the acceleration of the fan. Well, it says the force is going to be exactly the same, right? So if the force is exactly the same and the mass goes up, then the acceleration has to go down to keep that the same. So in this case, when you have two variables on the same side of the equation, they're inversely proportional. The slope of the graph is the acceleration due to gravity. Therefore, the changing the mass of the cart would not affect the slope of the graph. The y-intercept of the graph is equivalent to the initial acceleration of the cart on the horizontal surface. Because the force of the fan is constant, increasing the mass of the fan cart would result in a smaller acceleration. I would say maybe add this because mass and acceleration are inversely proportional for a constant force. Just to throw in that fancy-dancy language. Therefore, the y-intercept of the graph would decrease. Okay, something like that. So when they say explain how the graph would change, I guess I didn't need to say this, that the slope wouldn't change, but I did that just to cover my bases anyways. So those are all the parts of question 1. So let me go through and mark where I think the 15 points will be distributed. So I think they'd give 1 point for the force of gravity that are pointing straight down. I think they'd give 1 point for the force of the fan, making sure that it's directly on the dotted line. And I think maybe they'd give 1 point for no extra forces. Usually it's like 2 or 3 points here, so that's a really easy way to get points. For part B, let's see. So they'd probably give you 1 point for setting up the Newton's second law thing, and they'd give you 1 point for getting the correct answer. So that's 5 points total. Part C, probably another one here where you get the Newton's force set up correctly, right? And then another one here for getting the correct answer. So that's 7 points. Usually on these justification questions, they don't really care if you get the right answer or wrong answer, as long as you explain it correctly. So maybe there was a way that you could explain it. I can't think of it off the top of my head right now how mass might matter. But I think you could get either 1 or 2 points here. I think some statement either explicitly stating or implying that mass is independent of angle would be 1 point. And maybe that's it then. Maybe this is a 1 point thing. Or maybe 1 point here for showing that it's independent. I don't know. I'll just leave it at 1 point because how many am I at right now? I'm at 8 points so far. I need 7 more. Okay. So definitely this line of best fit is just 1, making sure it's going through the middle of the lines, or middle of the dots, excuse me. Another one here for using the slope to calculate gravity, and then also maybe somehow showing that this is equal to this. I don't know how they didn't ask you to derive it though. So maybe not. Maybe over here, that's where they'd give you the point, right? They'd probably want you to get the equation of the line here somehow, either by stating what parts of the graph are equal to the equation. So here's definitely one part. I think some sort of statement showing that the y-intercept of the graph would decrease there. I think another statement showing that mass and acceleration are inversely proportional also. So I think this part could earn up to 3 points by showing the relationship and explaining it that way. So how many points is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I have 2 extra points, so I guess my 2 extra points are going to be here. How could we get 2 extra points here? I guess showing the equation? I'm stumped here. I think I could only award a max of 14 points here. So if anybody has any thoughts on like how the extra point could come from here, I think there's another extra point that would come from here. Feel free to leave a comment below. I hope you found this video helpful. If you have any questions, feel free to leave a comment below. And feel free to subscribe to my channel too, since I'm hoping to release more content like this soon.